So thank you all again. Welcome. Happy Friday morning. Super excited to have such a great talk this Friday. We are, if you haven't joined us in the past for our code, new energy code series, welcome. And if you have been on the past talks, welcome back. Thank you for joining us. It's been a great series and we've had such great feedback. I also want to say upfront, none of us are code officials or professionals. We've been very lucky to have some of the OER folks attend and help us answer questions, and we've been in correspondence with them throughout the process. But this is, we are all engineers, architects, designers. This is not, we are not officials. So please give us a little bit of leeway with that. But we're just working through it the same as you all. And with that, Allison, I don't know if you want to go into the next slide. We can show our series.
Sure.
So as you know, today, April is our third in our series, and this is our talk on TEDI, our adorable, fierce, or cuddly TEDI, which I think we'll work through on this talk. But as I said, we had the overview discussion, the existing building, in January, March. Those are up on the BSO website or will be in hopefully next week. And we're going to continue the series through having a discussion on HERS next month, and then a building enclosure discussion. So the envelope deep dive in June, and that will be a co-shared discussion with the building enclosure and knowledge groups. So very excited, and then we'll continue moving on, just circling back to commercial as it enacts in July. So I will put the CUs and hand this over to the rest of the group who have spent so much pulling this together.
Good morning, everyone. I'm Allison Nash. I'm a sustainability coordinator at Sasaki. And today we're going to be following a similar outline to our previous talks, where we're going to review the stretch code compliance pathways, like which kinds of projects that the new codes apply to. We'll review the timeline and a little bit of context of why the stretch code is important. Then we'll dive into what is the definition of TEDI, what is this thing? We'll review a little bit of highlights about energy modeling for TEDI. We'll also have some building science about design levers, things that you can think about as you're designing your buildings. And then we'll end with about a half an hour of reviewing resources, and there'll be an opportunity for you to ask and answer questions. We do have Ian Finlayson online here to answer questions if the panelists aren't able to, or we feel like it's a DOER type of question. We'll have about half an hour at the end for that. Without further ado, you've heard Laura and I, we're moderators here today. Andrew Steigeser is a building scientist, passive house expert at RDH Building Science. Kate Bobrisky is an architect and principal at Arrow Street, representing that point of view. And Ale Menchaca is an engineer at Thornton Tomasetti and an expert really also in building science. So to go through the compliance pathways, there's been a lot of recent opt-in specialized adoption in the last week or so. We just updated this map yesterday. So right now there are 12 towns that have adopted the overlay of the specialized opt-in code, and we anticipate that will continue to grow as town meetings vote for this. However, it is important to know that the stretch code, the basic stretch code, does apply automatically across most of Massachusetts. There are only 49 municipalities or towns that are not green communities in the state. So really, it's important to note that the stretch code in its new form really applies to almost every type of project in Massachusetts, which is different than before. And how does this work? So The base energy code, we're expecting the BBRS to implement that in the fall. We're still waiting on that final date of when that will be. The base energy code and the 10th edition will be released. However, that energy code really only applies to the 49 municipalities that are not green communities. The rest of the state will either follow the stretch energy code or they'll have the overlay of the opt-in code in addition to the stretch code requirements. And this is just another way to look at it. We have the IECC 2021, which served as the model code. The base code is adopted from that. And then there's some Massachusetts amendments that'll be coming out part of that. However, most of the state is going to follow the base and stretch code with those 12 communities, and we anticipate more having to follow the opt-in code. So how do we know what this applies to? We've used this decision tree that was put together by a few of the Boston area sustainable design leaders, and it really helps you kind of understand, you know, if you're a residential or commercial project, how does that apply? So for the TEDI pathway, and we'll go into this in more detail later in the talk, it really applies to specific use types of buildings. So if your use type, energy use type is a dormitory or a fire station or a library, an office, a school, a police station, post office, or town hall, TEDI is a pathway you can use or, you know, there are other pathways you can use instead of TEDI, but TEDI really is a strong pathway for these particular use types, and it's optional for other use types. So diving into the timeline and when this applies and a little bit of background. The technical guidance documents were released last December. In January, the residential stretch code became in effect, and that's when some towns and cities started voting. Brookline, Cambridge, Somerville, and Watertown adopted quickly the opt-in specialized code, and we now have an additional 8 cities and towns where the opt-in code will be in effect in January 2024. This summer, the commercial stretch code will be in effect. We have a talk on that later this summer. We'll go into that. We also anticipate that the base energy code is going to happen in July or the fall. In January next year, the opt-in stretch code multifamily for less than 5 stories will be required to meet passive house. And in July next year, there'll be a lower HERS value required for residential. The relative performance path will end for commercial multifamily, and the opt-in specialized code for multifamily greater than 6 stories will be required to meet passive house. Go ahead, Andrew.
So in Massachusetts, decarbonization is now law. The recently adopted stretch energy code and specialized opt-in code take a leap forward in decarbonizing the built environment. And we see this through the introduction of some new metrics for building performance. Next, please. So the code is moving towards absolute metrics rather than percent better than, approaches like we've seen in the past. Through enclosure improvements like those required by TEDI, we reduce energy loads and mechanical loads. With reduced mechanical loads, we can reduce the size and energy use of mechanical systems, therefore lowering the total EUI and operational greenhouse gas emissions. Then we can lower the greenhouse gas emissions of the building, requiring less renewable resources to offset the remaining greenhouse gas emissions. And so now the code is moving towards these absolute metrics, some of which include passive house and TEDI. Next, please. So all the code paths are looking more at the whole building performance now. We're all familiar, well, a lot of us are familiar with passive house at this point, And Passive House is a compliance path for all buildings. Other paths in the code implement various elements of Passive House through multiple code requirements in different sections. This includes things like building enclosure improvements, air tightness, and heat recovery ventilation. Next, please. So what this does for us with some of these new code requirements is it really shifts the design process. We have to make the right decisions early in the process. The new code requires early phase energy modeling right up front to set design targets that then are followed through and verified throughout the design process. Versus the traditional time frame where we design the building, we take it through somewhere in DD. There's a hourly energy model to check if it's 10% better than ASHRAE 90.1. This is how we did in the past. And then, usually it worked and we proceed through permitting. Now, with the metrics in the code that are there, it really relies on hitting these set targets. So you want to know upfront if you're hitting that target, and then what modifications need to be made in order to hit that target right out of the gate. Next, please.
Great. So we're going to go into starting to talk a little bit more about the compliance paths in TEDI. So there are essentially 4 compliance paths in the commercial code. So today we're just talking about commercial. So that's commercial buildings and residential buildings over 3 stories. There's a prescriptive path, which is 20,000 square feet. And it's what it sounds like. It's prescriptive components for envelope and mechanical, electrical, hot water, solar ready, EV ready, et cetera. And then there's 3 modeling paths. There's the TEDI path that we're going to focus on today. That's the targeted performance path. There's a relative performance path, which is a little more on what people are used to with an ASHRAE modeling and XG. Then there's a certified performance path, which is getting certification through Passive House or HERS. And as Andrew mentioned, it's really focused on all of these paths being equal. That is the intent of this code, is that whether you are required to do a different path or choose one of the optional paths for your project, that you're really designing towards passive principles for your project. So with the TEDI path and the relative performance ASHRAE path, there are prescriptive components that you would see in the small project prescriptive path. You'll see those prescriptive components also applied to those 2 modeling pathways. Certified performance, those prescriptive paths are essentially embedded in those systems already, whether it's FIAS or PHI or HERS rating. Go to the next slide. So what kind of projects are required to meet these different paths, or which ones are optional? So prescriptive is for buildings under 20,000 square feet that are non-residential. So no residential projects can follow that path. So it's technically optional because you can always choose to have a small building and do one of the modeling paths instead. But most projects probably will go for prescriptive if they fall in that under 20,000 square feet. Next slide. When we start talking about TEDI, this is where you start to see requirements, as Allison was mentioned earlier, for specific building use types. Dormitories, fire police stations, libraries, offices, K-12 schools, post offices, town halls, and after July 2024, residential projects as well are required to be in that TEDI path. For the relative performance ASHRAE modeling path, it is optional for high ventilation buildings and basically anything that's not required to be in the TEDI pathway. So you can always choose to have a high ventilation building and design it to TEDI, but you can also choose a different ASHRAE path. And then there's the certified performance. That again is optional for any building, and HERS obviously applies to residential buildings only. So you can always, whether you're required to be in the TEDI pathway, you can always choose to go to Passive House or HERS pathway for your project. But if you don't decide to do the certified performance, then you are required to be TEDI if you fall in that sort of green color use types. Mixed use buildings can either decide to have each use fall into its own pathway that it's applicable to it, or you can do a whole building TEDI or Passive House path for that particular building. So with mixed use buildings, you have options, including having some spaces be prescriptive because maybe they're small, and then the larger use would fall under potentially TEDI and passive house or whatever's applicable to that use. Next slide. So when we talk about opt-in codes, as Allison mentioned, it's really an overlay on top of the stretch code. So there are some impacts if you're in a specialized opt-in community of what pathways are going to be available to your project. And so the main changes here are the passive house becomes a required pathway for residential projects for under 6 stories or over 5 stories, depending on the start date. And really that means that the TEDI pathway goes away for those residential projects after January. So that's the main difference here is that residential projects will have a requirement for passive house. They won't have an option kind of between TEDI or passive house in the opt-in communities. Next slide. So what is the targeted performance path? TEDI, which stands for thermal energy demand intensity, is the modeling component to this performance pathway, in addition to the prescriptive pieces that are required. And it's really looking at your annual heating or cooling demand. It's measured in kB2 per square foot per year, similar to EY, but it's very different than EY. EY is looking at your total energy use, including everything from heating and cooling, but plug loads and other load sources. We're really just looking at that annual heating and cooling demand. And again, it's looking at this passive design for your building and focusing on reducing the loads to minimize your energy. So I think it's important to think about that we're doing a modeling piece, and Ali is going to talk more about the modeling component to it. But just to remind you, if you go to the next slide, there is prescriptive component. Oops, sorry, that's 2 more slides. So here are just the targeted limits. So depending again on your occupancy type that's required to go through TEDI, you will see that depending on the size of your building, you have a different TEDI metric that you have to hit. So there's both heating and cooling, and obviously the heating is in red and the cooling is in the blue color. But depending on your square footage and your use type, you'll have a different number that you have to hit that will be the output of your modeling process. So in addition to doing the modeling and hitting those specific TEDI limits, you also have these prescriptive components. If you go to the next slide. So we're not going to get too much into the prescriptive components today. We're going to have a whole building envelope session coming up in June. But I just wanted to point this out today because for the code, and again, this applies to the prescriptive path, the targeted performance path, and the relative performance path, that there are some absolute minimums that you need to basically hit with your envelope. And it really plays into the TEDI modeling, as Ali and Andrew will talk about more, because these again are our minimum requirements, and you might have to adjust these in order to do the modeling process that goes along with this performance, targeted performance path. So there are requirements for the U factor of your walls. There is some allowance that if you, for all of your envelope components, there is some allowance if your above grade wall does not hit the U factors or fenestration window to wall ratio. And based on that, there's some other requirements to do a component performance calculation. And again, I'm not going to go into sort of the right-hand side of this decision tree, but just knowing that there is sort of starting a baseline of minimum performance for your envelope. And then there's additional things on top of it, again, really trying to focus on passive design and load reduction. So there's de-rating for thermal bridges that is a bit new in this code and requires much more focus on that in this code. There's mandatory air leakage testing, and then things like solar ready and EV ready as well. So just keep this in mind as we talk about TEDI, that it is a modeling path, but there's also a lot of prescriptive components that you have to hit these minimums. Go to the next slide. And one of them, again, is the air leakage testing that has to be a third-party test. And there's different requirements for the project, whether it's an RRI group or others. But this is required across all projects that are in stretched communities. So Allie's going to talk about the modeling piece.
Thank you, Kate. So in order to prove compliance, we're going to have to do what we're calling TEDI modeling. To be clear, the heating and cooling TEDIs, so the heating and cooling demand for a particular building can be extracted from any energy model. So you could go into any energy model of your existing building and take that number. However, under the new Massachusetts stretch code, the energy model used for compliance, which we're calling from now on the TEDI model, must follow certain DOER modeling guidelines. What this means is that your TEDI model will not necessarily be equivalent to what you're used to as your, as a proposed model. I do want to note that the new code does not require you to do a proposed design model, but you might still choose to develop a proposed design model for purposes like quantifying EUI, understanding how much PV you need to get to net zero, doing LCCA analysis for LEED compliance, et cetera. And so I anticipate that most projects are going to have a proposed design model, but you are not required to do that by code. We go to the next. These targeted performance simulation guidelines, many of you might have already read the original draft and then the updated draft that were published recently in the last 5 months or so. There is an updated draft that is incorporating a lot of the comments from the modeling and the design community based as a reaction to the original drafts. And those are coming, my understanding is anytime in the next couple of weeks. And so I want to clarify that there's a lot of guidance that we'll be giving here. We've been given access to the red line of the final modeling guidelines, but those have not been publicly released. And so we're not necessarily going to address specific details of those because we don't know the final as well. Go to the next. So what does it entail to do the TEDI model? And this is important if you're a modeler, you're an architect, if you're an owner, for you to understand how do things change? How is this TEDI model different from my actual model? The TEDI model is an energy model. It's using roughly the same software that was being used before. It is the same or it's equivalent to the proposed design. It matches the proposed design in its massing, its window to wall ratio, enclosure thermal performance, so R values, U values, air tightness, ventilation heat recovery, HVAC system and zoning. You are allowed to use the default HVAC system and zoning too within the guidelines, but in principle, you could just take, if you have a proposed design model, you could just take what you have and then start from there. How is it different from the proposed design? It's different from the proposed design in that there are preset occupancy schedules, standardized, let's call it, occupancy schedules that you will need to use. And so if you're modeling a school, you wouldn't necessarily be modeling the schedule that you're anticipating to have in the school. You would be modeling a prescribed schedule that is outlined in the guidelines. And the purpose for this is to be able to compare apples to apples, various schools, let's say, and so compare the performance between many of them. Same with ventilation schedules and rates, set points, HVAC system operations and controls. There will be tweaks in the HVAC and the controls, as well as weather files might change from what you are using for in your proposed design or what you're using typically. And so the areas that you really have control over in terms of design are the ones that are highlighted in blue and that you will want to optimize for your TEDI. Massing, window to wall ratio, enclosure thermal performance, air tightness, and ventilation heat recovery. We go to the next. I do want to note a couple of things. The TEDI model should not be used to predict energy use. Why? Because the occupancy schedule is not necessarily what you're anticipating to have. Your ventilation schedule is not necessarily what you're designing it to. Same with the HVAC systems in operation. You might be designing your building to have a particular operation, but the TEDI guidelines require you to change that and use something else. And so that whatever annual energy use you get from the TEDI model is not going to be representative of what you should anticipate for your project. And so you should not be using the TEDI model for that. If you want to know your EUI, you would need to run your proposed design model as we're used to doing in the past. The other thing is that some strategies, because there's certain things that differ in the TEDI model from your proposed design, it is possible that some strategies that are lowering your TEDIs, again, your goal is to get under a particular TEDI value, right? A heating TEDI of say 2 and a cooling TEDI of say 14, right? And so you're going to be playing with these values with your massing and trying to improve it and working with your A tightness, et cetera, to lower your TEDI. Some of those could potentially increase your EUI. And because the TEDI model is not reflective of your EUI, you would need to understand, if you want to understand if there's an impact to EUI, you would need to have a proposed design model to understand that. And so while it's not required by code, it's probably a really good idea to have it. We go to the next. So as a reminder, this is what the thresholds that you'll be aiming for look like, right? It's, you don't need a, don't pay too much attention to the equations, but basically if you are, office, police station, et cetera, the first category, your heating TEDI is will have to be anywhere from 1.5 to 2.5. And your cooling TEDI will need to be anywhere from 23 to 21, depending on how large your building is. And so you'll really be using your model to fit within this absolute threshold. And if you're designing 5 different libraries, even though they're very, very different and their massing is completely different, all of them, if they have roughly the same square footage, they'll need to meet exactly the same value. So as Andrea mentioned, we're now in an absolute metric. We're not in a relative metric where you're compared to a baseline that's, that's unique to your particular building. So just to close in terms of energy modeling, this is a comparison of what is changing with the 2020 stretch code and before. It's not uncommon to do the Massachusetts baseline model around DD or later, even backstop envelope calcs anywhere around DD or later. Some of us are doing them earlier, but again, it's not uncommon to see teams that are really starting to do this, DD or later. With the new stretch code, the answer is as early as possible for everything, right? In our experience, achieving the TEDIs can be quite challenging. And so fine-tuning the design is extremely, extremely, extremely important to be doing that very early on. And so whenever you can kick off, and so if you're writing a scope or you're reviewing a scope for modeling, and it says the code model will start in DD, that's a red flag. You should really be starting as early as possible, as well as your backstop envelope calculations. And so you need to make sure that someone has that scope and someone is advising you on that. If you have a proposed model, as well as, you're going to have a TEDI model and backstop calcs, you should be running those concurrently anytime there's a major design alteration, just to make sure that you're keeping track of your compliance. But also, if you care about EUI and say you have an agreement with the utilities and you have a particular EUI cap, right? You're aiming for 25 or whatever it is. You do need to make sure that everything you're doing meets TEDI, meets backstop, and meets your EUI goals. And so do all 3 concurrently. In terms of informing design, again, until July 1st, a proposed model is required because you're doing a NASH rate comparison, right? You're using really your Massachusetts baseline model for compliance, and then passing the backstop envelope is often sufficient to know that your envelope is good enough, right? And so far what we've been doing is saying, well, let's just do a backstop envelope calc and make sure that you're within the threshold. This is in the current code. And then if you're there, then you're good. Then just run your model and let's optimize HVAC systems, et cetera. But your envelope should be good enough. With the new stretch code, again, as I mentioned, you don't need a proposed model, but highly encouraged. You're going to be using the TEDI model for compliance. And this is very important. Passing the backstop envelope is often not sufficient to meet the TEDI. What does this mean? That you can't just do the backstop calc and say, okay, now I know that I need an R value of X and a U value of Y, and my window to wall ratio is this, and I'm good. No, backstop envelope is becoming a little bit more like a minimum requirement and minimum compliance, but you still need to do the TEDI model and you might need to improve that. Some other examples are, your infiltration will probably need to be, your air tightness will need to be lower than the 0.35 that Kate pointed out as the minimum compliance, right? And so if you're just following minimum compliance with 0.35 CFM per square foot at 75 pascals, your TEDI might not pass, right? Your TEDI model might not pass. And so you might need to have a higher air tightness. And so again, I can't stress it enough, running the TEDI model as early as possible is key. In terms of modeling process, if we go to the next one, as I mentioned, really doesn't change, nothing changes in terms of software. So if you're using, or whoever's doing the model for you is using eClass Energy Plus IES, same is happening with this. You can do your TEDI model with that. There will be a full session on backstop envelope. And so I'm not going to get into the details of it, but big picture with backstop, you were doing a full envelope UA calc, meaning roof and vertical, and so vertical and horizontal surfaces, whereas the new stretch code is really focused only on the vertical piece. And so that changes a little bit too. And so you should know, and also thermal bridging, I should mention, that's probably the biggest change, is that accounting for thermal bridging now is much more elaborate. I would say you're going to have to account for thermal bridging also in the inputs you put in the energy model. And so again, there is strong arguments to start with understanding what is your derated envelope performance really early on. And then finally, as was pointed out, really the biggest difference is that we're used to being a % better than a baseline that is unique to our building. This time around, we have an absolute number for TEDI, and the modeling guidelines are going to lead to a model that will most likely not be very representative of your actual building, right? And so you need to get used to that, and we need to understand that the whys for that. And from backstop envelope, you're just changing from 9th edition to 10th, as I mentioned, the different requirements. And so that's it from the modeling side. Thank you.
All right, design levers. So in our consulting, we talk a lot about the energy budget and the key levers that affect it. If you know Passive House, you know a lot about TEDI. A lot of the same key levers are shared between the two. TEDI is a metric focused on performance of the building enclosure, and it considers heat flow through the enclosure and air infiltration. It encourages us to build better and more insulative and airtight enclosure systems. And as Ali pointed out, those inputs are fed into the TEDI modeling, so it's important to account for these accurately. And the key levers can be pulled based on the project priorities. So you can trade off between them in balancing the energy budget of the project. And the key levers are tied into the updated various code sections. The things that go into the TEDI modeling, the inputs, have various requirements throughout the code that would encourage you towards, more ideal inputs towards the TEDI modeling. And the TEDI attacks the building's heating, really, heating and cooling, but particularly in the heating TEDI, that's where a lot of the on-site combustion of carbon-based energy sources are used. And that's, one of the things about TEDI as a metric is it really, rather than the whole EUI, TEDI may look at like a small piece of that EUI, but when you zoom into it, you can really reduce those heating loads up to like 90%, similar to Passive House. And by doing so, you're really attacking the on-site combustion of carbon-based energy sources. Next. So some of these key levers that go into the energy budget that help us towards our TEDI model. So, before we even get started, the building's massing alone can impact how much heat is lost through the enclosure. This can influence TEDI before we even touch the R values or U values of the enclosure. More complex shapes or over-articulating the building massing can increase the envelope area, which, compared to the volume, becomes less efficient. And having an efficient form factor, the measure of that area of enclosure to the areas of floor plates or surface to volume ratio, two separate metrics that look at a similar thing. Having a more efficient form factor and reducing the envelope area relative to the building volume will make it easier to achieve reduced heat loss. Next, please. So, another one of those key levers is the glazing system. Moving forward, if we choose to use a lot of glazing, it will have to perform really well. We want to minimize heat loss through it. So we may have to be more selective about our glazing design priorities within projects. Mullions are the worst performing part of a glazed system. And so therefore, having more glass relative to less mullions within a system will perform better than the system with many mullions. And so that's something to be looked at carefully when running the UA for the enclosure. That can really affect that installed U value of that glazing system that goes into the TEDI modeling. Next, please. Another factor related to glazing is the solar heat gain. So if you follow the component performance alternative requirements for glazing in the code, section C4 2.1.5, you're going to be starting off on a pretty good path towards your TEDI model inputs. Of course, you have to run that model and see for your project what your specific enclosure requirements are, but that's already a good start. And the enclosure performance, of course, is confirmed through the energy model, but the goal here is to balance the solar heat gain to satisfy both heating and cooling TEDI. The heating TEDI limit in this climate zone may be the more challenging target. I mean, and there comes a point where you're pushing that down and maybe the other one goes up. So it's a balance. And of course, you don't want to rely wholly on your solar heat gain coefficient in the glazing. You might limit the percentage of glazing before you do that. So again, it's a balance of all these things towards getting your model inputs to yield your result, hopefully under your TEDI limits for heating and cooling. Next, please. So, as Ali mentioned, there's a lot more accurate accounting going on for what goes into the inputs for the TEDI model now. So, again, the goal is to more accurately predict performance of the buildings and to make them better. So we do this with an enclosure performance target. And again, that target may be project specific per the TEDI modeling. And, what is the heat flow when enclosure elements aren't floating in space? It's kind of the question, as we looked at it, little pieces in the past. This is more accounting for the heat flow through the whole building, including interfaces of assemblies. And we look at this through points and lines, the Chi's and Psi's, and the enclosure is derated as described in the code to yield a clear field R value that more accurately reflects the heat that's actually being lost through that assembly. Next, please. So you do this for opaque walls, and you also do this for glazed systems. For glazing, the code requires limits through the section 4 2.1.5 on the glazing area weighted U values. And the code requires either 2D or 3D finite analysis now. So those therm or Flixo models that we've seen in the past, and code specifically requires 3D finite analysis for curtain wall spandrels, most of them, because it requires the 3D analysis for anything with multiplanar heat flow. So like this example here, a recent curtain wall system, with custom system we looked at, even with all the thermal breaks and mullions that don't go all the way through the back pan and all this insulation, we found a clear field value of R9. And you see through the heat flux that in 3 dimensions there's a lot going on beyond a simple 2D cut where heat flow occurs. So that's sort of the idea with the multiplanar heat flow. And there can be large discrepancies between 2D and 3D modeling. And we sort of caution relying on 2D unless it's really clear how it's being carried out, or if it's a clear-cut case of, anything beyond that 2D cut is, extruded beyond. And this is critical, particularly for TEDI energy modeling, that there's not an overly optimistic accounting for clear field R value. If there is, there's a major risk of a delta between the modeled and actual whole building energy performance. Maybe you could, be a little more optimistic in your TEDI input and maybe show the model to work, but there's the actual performance of the building, and there's a lot of things that could, result poorly if your actual performance is not matching the modeled. Next, please. And again, a little more on glazing systems. So the code requires that we be consistent in our accounting for gains and losses through the enclosure. And that includes for glazing, the center of glass, the frame, and the edge of the IGU. It's kind of similar to what Passive House does too. NFRC and Passive House are ever so slightly different. Passive House also includes that SI install, the heat transfer through that flanking condition of the window rough opening. NFRC doesn't so much look at that, and that's not something that's going into the TEDI model necessarily. It's just the glass, frame, and edge. But it's simply not your center of glass U value. It's accounting consistently for this, and again, the frame is generally the worst performing part. So we have to look carefully at the design and the layout of the mullions. Next, please. So in the code now, there's also air tightness requirements, and again, for those of us familiar with Passive House, that's nothing new, but it's making its way across all code compliance pathways now too. And the goal is to achieve the modeled air tightness in the actual building. TEDI is counting on a certain air tightness in the model, and we want to make sure that's achieved in reality through construction and operation. So the best defense is to carefully detail the enclosure, particularly at transitions between assemblies. Like, we're not leaving this to last minute in the field. We're being proactive through design, looking at the enclosure and the detailing, which often ties into the larger design. So that there's more than one way to skin a cat, and so we want to look at the most ideal way from the get-go if we can. So, and in construction, collaboration is necessary with the GC to make sure all trades touching the enclosure are clear on air tightness priorities as well. So there's that step between carefully detailing, making something feasibly constructible, and then clearly communicating that to all parties, realizing that, and then careful field observation through construction helps catch potential enclosure deficiencies, all the way along while they're still accessible before your air tightness test. And so the code defined limit is 0.35 CFM per feet squared of the enclosure at 75 pascals. So it's it's relative to the amount of enclosure you have. Which is similar to what FIAS does in Passive House. To note, their air tightness requirement is 0.08 CFM per foot squared at 75 pascals, 0.08 versus 0.35 across the code. So it's still not quite as stringent as say what Passive House would require, but it is a major improvement upon what we've seen in the past. Next, please. And as Ali really drove home, again, it's important to set design targets early with an early phase energy model. This will inform things like the efficiency required from the heat recovery ventilation, which is also now a code requirement as well. And that's a factor that goes into the TEDI modeling as well, the percentage efficiency of your HRV or ERV. And if that model is done early in the process, you know what you have to achieve for percentage efficiency from that equipment. This will inform early phase cost estimating as well. As well as being able to identify what is available for use in that particular project. If the efficiency required proves problematic in the modeling versus what equipment you can get on the project, another key lever can be pulled, but it's gonna make certain requirements more stringent in one of the other areas in the to balance that energy budget. So, and unlike the design of the enclosure, there's only so much you can do with the efficiency of ventilation. So at some point it maxes out. So it's really important to consider ventilation in balance with all the other key levers in the project that go into it, including enclosure based on that modeling. Next.
All right, so we just went through a lot of very technical information, and there's some excellent questions in the chat. But first, before we get to the questions, I just wanted to show you all our resources screen, which I can leave up during Q&A for some of it. NEAT, the Northeast Energy Efficiency Partnerships, has a lot of great guides that are very general. They've also released 3 very short videos, just give a few highlights of the code. They're not in depth as the BSA talks that we've been giving here. There's also links here to the draft modeling guidelines, the technical guidance document, and an unofficial 10th edition, as well as our contacts. I also wanted to point out that the state has been very good about updating the opt-in specialized code map pretty regularly, but we also have some, Jamila Schaefer is also mapping the development of how many towns and cities are adopting the opt-in code. So that link is here as well. All right, so I'm going to stop sharing so we can see each other's faces, and I will go through the questions that we received in the chat. I think some of them are already answered. So let me go back to the beginning here. All right, so there was questions. I mean, there were some comments about the maps and who was on what list that we'll make sure and fix. And the first question is said, please clarify, TEDI is heating demand or amount of heating delivered to a space. Chris Schaffner responded, it's the coil loads. Is there any other response to that question from our panelists?
Yeah, I think I would just hone in on the concept. So what it is and how it's measured, I would say is perhaps slightly different just because we're using an energy model to measure. But what the TEDIs are how many watts do you need to put in a space, and then overall in a building as you add it up, how many watts do you need to put in of heating, regardless of whether you do that with a candle or a sophisticated HVAC system, is how many watts does that space need to stay at a particular set point at particular times of the day, and warm up its ventilation air, its incoming fresh air to a certain temperature, and then how many watts do you need to remove in the cooling season, whether you do that by opening windows or with whatever system. And so ideally, if the model were exactly quantifying that identically, these two numbers would be exactly the same. The models are not perfect. There's certain hours that are unmet, et cetera, but you would be measuring the modeling guidelines have very specific instructions as to where you identify the outputs in your model that are going to give you that number, if that makes sense. But in concept, those two should be similar.
Thanks. Yep.
Great, thank you. Then there was another question about the certified performance standard compliance, whether there was a certificate for that. I'm trying to find the other. I think that's
Yeah, my slide
something that's
said
prescriptive. Yeah. Do you want
that
to
it
go ahead and
wasn't
answer?
required. Yeah, it is required for,
Okay.
if you do the certified performance, you still have to have that certificate in your mechanical room at the end. So,
Okay. Then Keely asked if the timelines change for when each pathway is applicable or not. Is the timing determined for when the building is permitted, or is there another time? And Ian replied from DOER, yes, the code requirements are based on the date that the complete permit application is accepted by the municipal building code office or inspectional service department. So when the permit application is submitted rather than when a permit is issued. Ian, did you want to add anything to that?
Not unless there's any lack of clarity on that.
Okay.
I think we want the date to be in the control of the design team rather than being at permit completion, which would be dependent on how quickly it's turned around by the local code official. So that's why it's the date of submission of application, which typically that will get like time and date stamped by the authority having jurisdiction. So it's a good question, but I think the answer is pretty straightforward.
Right. Thank you. Chris Schaffner from the Green Engineer had a question about definitions of the building use types and had a specific project question about a standalone gym at school. I think this is an excellent question for you, Ian. How the building use types are defined. Do they match with the building code definitions of occupancy types, or how should folks be looking at the use types in regards to the code?
Yeah, and again, this is a good question. So we defined, well, we didn't really define, we listed some building use types that would be covered under TEDI, and then there's a whole gamut of adjacent building use types that we are essentially going to have to build out through precedent, because sometimes you have a town hall that has an adjacent use, or Chris's example of a standalone gymnasium. So we haven't defined everything that's in TEDI versus allowed to use the ASHRAE pathway. And I think we will be sort of regularly updating guidance just for that, so that people know what's in and what's out. And so the early projects that are in that gray area, I think will help us define, is TEDI required for this building use type or not? Which that may not be the answer everybody wants. People like clarity, but it does allow us to have a little bit of flexibility in the early stages of figuring out the best application.
and how does the project team go about getting clarity as they're trying to design?
Yeah, in the short term, I would say email stretchcode@mass.gov or Paul Ormond and I, and we'll probably have to set up a call and walk through that, and then we'll try and turn around and maintain. So we have a larger project to sort of maintain a database of early TEDI compliant buildings, just because we think that will be a very useful reference point for all design teams to see what types of design strategies people are using to comply with TEDI. But then also I think we'll maintain a list of what is covered by TEDI and what is not covered by TEDI for all the building uses that are on the margin.
Great, thank you. yeah, there's some more in the chat. There's some more detailed follow-up between Chris and Ian about a gym within a school building, whether that would apply to TEDI or not. So I think this question of adjacent types and exactly, for higher ed, what pathway is required. It's good to know that what the process is for that. What I'm hearing is DOER will accept an email and then a phone call to discuss the particulars about the project, and then we'll decide a pathway, and that can be documented in some way that the AHJ or the ISD that's in charge of that project can have as a record.
And Allison, if I may add to that, particularly in the school gym within the school question, I encourage everyone to check, particularly as new guidelines come out, but you can even check the older drafts for the guidelines. There are zone typologies defined for every building typology. So say a school building will have a classroom, like a zone type, a space type, and then a gym space type and a cafeteria space type, right? And so if the gym is the gym that belongs to the school, there is already a guideline in terms of that. And so we've had questions with respect to other spaces, like how does the library fit within the school? How do I categorize that into these three different categories? But the gym question, if this was the gym for the school, that one is a straightforward, you just model it as the gym space type within the guidelines that are provided for a school.
Thank you for that. Gary Brock from HMFH asked, he picked up on one of Andrew's slides that he had some language around optional blower door testing. What Andrew meant as a best practice, actually, which Andrew and a bunch of us passive house professionals understand from working on buildings that are trying to meet more advanced air tightness. It is very important to do blower door testing during construction rather than after everything is done, so that you can find where the problem areas are in the construction process, and the contractor has a chance to correct those before everything is done. So I think that was what was on the slide. Andrew, if you want to talk to that, please go ahead.
Thanks, Allison. Well, I think you covered it. I mean, you can rely on your final testing, but that's exactly it. If additional QA QC is required during construction for the enclosure, there could be an intermediate blower door test at some point once the enclosure is complete, windows are in, primary seals are all completed, the building's airtight, but perhaps before interior finishes are applied, or perhaps before cladding goes on while your air barrier, if it's outboard of the sheathing is still accessible. And again, it's often those connections between assemblies that are problematic. So, an intermediate blower door test could be combined with, like a smoke pencil, or if the delta in temperatures indoor and outdoor are high enough, some infrared imaging in combination with the blower door test to help sort of, make that a clearer image to pinpoint, potential problem areas, like you said, before construction is complete. So that would, catch some things that can be modified before the final.
All right, the next, thank you, Andrew. The next question in the chat is again from Chris Schaffner. He says, I feel like the speakers are understating just how hard it seems to be to meet the TEDI numbers. Do any of you have projects meeting the TEDI? What kind of insulation, glazing, and infiltration numbers are you seeing on compliant projects? Just to set the table on that, Chris, we felt like this talk, it was important to give people an overview of what TEDI is, since it's a new pathway. And since the modeling guidelines have not been finalized, we're still kind of in a kind of wait and see testing I also want to emphasize to everyone here what Kate had said at the beginning, that the various compliance paths in the code, unlike in previous codes, they're all trying to be equivalent. So if you're meeting passive house, your TEDI model should be kind of at a passive house level of performance. So that is a different way of thinking about the code. In the past, our building energy code has had some various performance, you weren't necessarily, like, if you were percent better than, or you're prescriptive, you're not necessarily the same building performance. So I think that's a different way of thinking about the code, and that kind of helps get into that. Ale, do you want to answer this from the modeler's perspective?
I'm happy to do that. And I see that Rosie and Ian have their hands up. And so I don't know what time, but if you want to just jump in and interrupt me if your comment has to do with this, speak up. Chris, thank you for pointing that out. Many of you know that I probably would have brought up this question if I had been on the audience side. And so we, as Allison mentioned, our focus of this presentation was really to give an overview of what it is. As I mentioned, I did try to stress that as early as possible. It's kind of when you need to do your TEDI model. We have been having a hard time meeting the TEDIs. And in fact, I would say until last month, we believed they were not reachable. Let's put it that way. Many of you have heard me talk about this. We've done a couple of models and we weren't able to get to that. We have gone through a very productive process with DOER, where we've given them our models, and they've given us feedback in terms of how to reduce the TEDI. A lot of it has to do with how the guidelines were written. And so we've done the model based on the last draft of the guidelines. And those guidelines did not address every single box that had to be checked to actually get to that. And so, as I mentioned, I feel that some of the challenges that some of us who are trying to meet the TEDIs are facing are that we are kind of stuck in the proposed model, like, this is what my building is doing, and therefore I'm modeling it exactly as it should be. And with lack of guidelines, like as the guidelines have been developed, well, there's certain areas that just were gray and weren't touched. And so DOER has been expanding the list of things like, oh, that's a really good point, we should add it to the guidelines so that it's clear that you should actually not be modeling this, or this should be modeled in a different way. And as a result, I can personally say I'm more hopeful in terms of meeting the TEDIs themselves. I am a big proponent of having, please, even though it's not required by code, have your proposed model that actually informs your design, because your TEDI model will not necessarily be telling you what your EUI is, and you should not be using your TEDI model for LCCA, right? And so that proposed design model is what should be reflecting what your schedule is going to be, what your HVAC, what your controls, what everything is going to do for, for the building, and how you quantify EUI and everything else. The TEDI model is just a different concept. What we're just, for DOER to be able to compare apples to apples, they need us to follow certain guidelines that might not be representative. And so we've been stuck into that, and that how representative is it? How representative is it not? And so I'm really hopeful that with the updated guidelines, there's much more clarity for everyone in terms of how to get to the numbers that DOER put forward, which I feel that in general for everyone felt really low. But if there are particular guidelines that indicate how to help the design get there, we'll hopefully all get there with good design. I'll just, in terms of envelope, so that just has to do with the model itself. So there are ways and checklist that will allow us to get the model and at a low enough starting point that then your envelope does the rest to get you to pass. We are using passive house level, I would say, envelope properties. In most cases, so most of our buildings we're telling our clients triple pane glass is what you need, period. We can test double pane glass, but triple pane is really what's going to get you there. In terms of envelope, same, code minimum, what we used to be code minimum is probably not going to be enough. So where can we add more insulation here and there? And since I'm on, and I'll just add one thing because I just saw this question come up. Have we modeled the safe building as passive house in TEDI? We have not done that yet. Because this process has only started for us in terms of modeling. I would say, is passive house easier? Yes, in that you're going to have to meet the same, I mean, yes, and no, I don't know how to put it. It's two different processes, but your performance is going to have to be the same. And so ideally, the goal of TEDI, and Ian, correct me if you feel I'm off, but the goal of TEDI was to give an somewhat simpler path to buildings that would meet similar performance to passive house, but didn't need to go through something that for some people feels overwhelming in terms of a process. Let's be clear, the overwhelming part of passive house is making sure that you're on track in every single step. And so that once you get to the end, you're not wondering whether you're going to pass or not, right? And so it's what process you choose, but it was really to give an option to not, you can't quite force everyone to go through a third-party certification, right? And so to give an option for equivalent performance. And so is one easier than the other? I would advocate that if you are curious of a passive house, you should probably try it. And you will find that at the end, it's probably going to be easier to just feel good about your building performance and everything else. But in an ideal world, TEDI is a way to allow for those projects who did not want to go for passive house for, a variety of reasons to meet the same performance and still meet code.
I'd like to jump in and add to that, Ali. That's a great point. That's a really great way of explaining it. I deal with passive house every day now. The nice thing about passive house is going through the third-party certification. Everything's sort of taken care of with that certification before you permit or get your C of O. It may end up being a little more straightforward for the AHJ because they get a package that's already been approved by a third party. And also, your CPA, your certified passive house consultant through the process is gonna, like you said, every step of the way kind of check up on things. So there are sort of QA/QC processes baked into the passive house process and design and certification process that may make some things conceptually simpler. TEDI tries to do a lot of the same things in other areas of the code, but yeah, sort of towards the same goal. But passive house seems a little simpler to me at this point in time. And the interesting thing, one more thing about TEDI too, TEDI as a metric is a useful metric because it does attack a really important area of the energy budget. And RDH has offices in Vancouver and Toronto too, and TEDI has been in the code for a little while there, and there's a lot of buildings meeting that there. Again, the specific guidelines and how the inputs go are different there versus here. So we're still, I think, working through implementing that in Massachusetts locally, but it is something that is widely recognized as a useful absolute metric towards reducing carbon emissions.
I see Ian's hand up. Did you want to respond as well?
Yeah, I don't know if I'm jumping the queue, but I did want to weigh in on this topic. So the intent from the outset from DOER's perspective is that TEDI would be more like passive house than the current sort of ASHRAE Appendix G model. And I think we clearly delivered that. It is more like passive house, but also be less stringent than passive house. So it's interesting to me to hear people say that passive house might be simpler or easier. Just sort of looking at some of the metrics, we would say that the air leakage requirements in passive house are more stringent. I think we would say that the peak load requirements are more stringent in passive house as well, because TEDI is spread over a year, so you've got a bit more flexibility. I think the glazing requirements in passive house are also slightly more stringent, although I hear what Ali's saying, that triple glazing is a sort of safe strategy for TEDI. Definitely helps. but you do have a bit more flexibility on the glazing. So the intent from DOER's perspective is that TEDI is moving the design industry towards passive house approaches, but not going all the way to the stringency of passive house certification. Now, being a third-party certification approach, passive house has a lot more what I would term sort of scaffolding around, not literal scaffolding, but sort of hand-holding support through the process. And there is that sort of step-by-step process, and you've got a third-party consultant helping the design team through it. TEDI doesn't have that, right? So it's you're kind of free climbing as opposed to having the rope of your passive house consultant catching you anytime you fall. We recognize this is a big step for the design community because it is so different from the percent better than ASHRAE approach. But our hope is that as we figure some things out, and we're certainly learning a ton from the interaction with design firms, and we get more clarity on the guidelines. For example, I think we messed up on the weather file for Massachusetts. And so we're asking in the new guidelines, everybody to use a Boston weather file, unless your local weather file is advantageous to you, you might as well use the Boston weather file. That's not ideal, but it does allow for that apples to apples comparison that we're looking for. We're looking for all buildings to be that are in these use types to be very solid from an envelope and heat recovery or energy recovery basis, to have some thought in the glazing strategy and the shading strategy. So all of those passive house principles being brought in for the first time is a big departure from the ASHRAE modeling approach. But our hope is that as this matures and settles down, it will be seen as less stringent than passive house. And if it isn't, then we may consider modifying the code accordingly to achieve that.
Thank you, Aaron. Rosalind, if you'd like to go ahead, and you've had your hand up for a while, go ahead and ask your question, then we'll get back to the questions in the chat.
Thanks, Allison, and thank you everyone on the BSA team for putting this together. So yeah, I have a few comments. I've really appreciated the opportunity to collaborate and discuss this with many of the people here. I think as a starting point, just building on Chris's comment of how hard is it to meet the TEDI, and how similar is that to passive house levels of insulation. So I think it's important for the envelope design community to understand what the starting point of envelope component performance is before a model is done. And the current code I find very misleading in that regard. There is the backstop calculation. There are minimum U values for walls, windows that roofs that can be met prescriptively if you follow the prescriptive path. And then if you're greater than or less than 50% glazing, then it shows a weighted average U value that needs to be achieved. But what we found from doing our experimental TEDI models is that those values are nowhere close to being compliant with the TEDI. So we find that very confusing just for the whole design team. As Allison pointed out, we don't have the final modeling guidelines, so we don't actually know how hard it is to meet the TEDI, or what some of those insulation minimum values might actually be. But to me, I find it very confusing that there's like the envelope performance minimum as written in the code, but that's actually a decoy to confuse us, because those values won't meet the TEDI. So some of the folks on the call have heard about a police station project we're looking at, only 19% window to wall ratio, basically a cube. triple glazing, and every envelope component was better than code. When we did this TEDI model, we were 6 times over on the heating TEDI. When we put in the TEDI modeling guidelines, which, as we discussed, are not yet finalized, when we put in the TEDI modeling guidelines, it was still above the heating TEDI, maybe double. When we improved the wall performance a little bit more in the model and brought the infiltration rate all the way down to passive house levels, 0.08 CFM per square foot at 75 pascals, then we were able to show meeting the TEDI. So if the minimum infiltration performance, for example, is shown as 0.35 CFM per square foot at 75 pascals, but that value actually is not compliant with the TEDI, then that's very confusing for the team. And I'm sure everybody here is working on projects that are already permitted under the new code. So especially if the TEDI compliance path is in fact supposed to be less stringent to meet than the TEDI, but we're finding from our models that it's equally or more stringent. I think some of my colleagues even said that their passive house compliant projects could not meet the TEDI. This really puts us in a difficult spot for our current projects in design right now, because we don't understand what the envelope performance needs to be. So those are my comments at this time. So I'm looking forward to seeing what happens here. I feel like maybe I'm a lawyer who has to defend a criminal, and the criminal is climate change or something for arguing with the code at all. That's not the case. I strongly support the intent of the new code. I want to get our emissions in Massachusetts down to 0 as fast as possible. But I also want to be clear to the design team what envelope performance needs to be met, preferably before we do a model. Not that I don't like doing models really early in the design process. That's really helps us make decisions when there's a chance to do so. But to have, the envelope backstop calculation, we did the whole calculation for over 50% glazing and it complies, and we calculated thermal bridging, but actually that whole calculation was junk because it didn't meet the TEDI. I think that just slows down and confuses the design process when the whole team is working to do a high performance design.
Thank you, Rosalind. Ian, do you have any response to Rosalind other than modeling guidelines are coming out?
Yeah, no, I do. And first of all, I want to say for all the people who feel like they're reluctantly pushing back because they want this all to work, we really do appreciate you pushing back, and we really do want to hear where you're finding challenges, because that's how we're going to improve the code language. That's how we're going to improve the guidelines. That's how we're going to pave the way for everyone coming after you to have a better understanding of how this works. So I don't want anybody to feel badly about saying there's a problem here. We want to hear that. That said, so far, we feel like the models that we've received, we've been able to kind of walk through and find solutions for. So my colleague Paul has really been leading that effort on our side with help from model consultants from Cartman Consulting and Stephen Winters and others. And we do want to keep going with that process. And we're looking to fund additional work in that area so that we can build this kind of best practice data set around the early TEDI models. And I totally appreciate that you all are the first generation doing this. You're the first group to do TEDI outside of British Columbia. And our TEDI limits and our climate is more stringent than British Columbia's right now. So So I just want to say, really appreciate that. We have yet to see anybody submit a model to us showing that Passive House is easier. But if anybody has done, and I don't expect that anybody has the time to do a Passive House model and a TEDI model on the same building, but if somebody were to do that and submit it to us, I think that would be very useful. We are looking for data, and we're looking for ways to streamline and improve the TEDI process. And the idea here is not to make your lives hell. It is to make building good buildings more straightforward and verifiable. And I'm sure there are days when it doesn't feel that way, but that's certainly the intent. So
Ian, we did submit a model to Paul Orman and reviewed it with him that showed we could not comply without Passive House levels of infiltration.
yeah, and I am curious about why that is. We're trying to better understand why that is. I agree, for that model, air infiltration did come down to Passive House levels. I don't think that's going to be typical. And it wasn't our intent that you would have to use Passive House level air infiltration to comply. So I think this is where we need sort of more data points. We've also seen other models that haven't had to do that, right? So we're building that that knowledge of what is driving these TEDI performance levels. So I do think you've got the worst case scenario that we've seen, and we need to see some more models.
So our model was actually, it's basically a cube. It's a police station, only 19% window to wall ratio. And we actually had it peer reviewed by Alejandra's company, Thornton Tomasetti. And our colleagues, many of whom are on this call, have found similar results. I think even some mentioned that Passive House compliant projects couldn't meet the TEDI.
Yeah, and that's something we want to verify, right? We haven't seen anybody actually produce a Passive House compliant model that doesn't comply with the TEDI. So people can say that, but it doesn't mean a lot unless there's something we can look at to do that. And you know, Passive House is an allowable alternative, but we don't want people to feel like they have to go to Passive House because TEDI is too hard. So
oh, that is how a lot of us feel right now.
Yeah,
because at least the process makes more sense. And
right.
Are those permits are coming up? Permit dates are coming up.
Yes, I recognize that. So you know, let's continue the dialogue and let's figure this out so that, you know, Passive House remains an option, but not the perception that it's the easier path to go to. That's not the intention.
Thank you. I think we have time. I'm looking at the chat, and I think a lot of the questions our panelists have tried to answer within the chat. And I see that Prachi Sharma's hand is up, so I'd like to give them the floor for a final question.
Thank you, Allison. I hope you guys can hear me okay. This is a follow-up to Rosie's question and my question in the chat as well. I think it has changed a little bit. So in the case if we find, or if the OER finds that there are a lot of projects that are not meeting TEDI without actually going down to Passive House levels of inputs for envelope and air infiltration, can the code then change, or would there be like this opportunity to have Passive House level inputs be prescriptive in the code? So like without getting the certification of the Passive House, like without getting the entire Passive House certification process done, we can still include those parameters in the code, in the stretch code, as prescriptive requirements. And I'm sorry if this has already been talked about, and because I didn't hear that, I'm sorry.
Yeah, no, if I can jump in, again, I think it's a good question. So historically, like there's been a prescriptive path in the IECC and in ASHRAE for buildings of any size. And I think we decided maybe 12 years ago that that probably wasn't the future, at least for large buildings, that the building is a system and a prescriptive path is always going to be a blunt instrument for achieving high performance buildings. And so the prescriptive path, as you see it now in the stretch code, really is designed for small buildings. And we essentially cap it at 20,000 square feet because there's an awful lot of buildings under 20,000 square feet, and we felt like it was just too much to ask them to do building modeling and figure all that out. So I know historically you've been sort of able to look at the prescriptive requirements and say, if I build this prescriptive box or building in any size, then I'm going to comply with code. That's not really the way we're thinking about commercial code for large buildings anymore. And then there, we could get into some of the challenges with prescriptive code, but one of the big ones that we are addressing even for the prescriptive path is the thermal bridging that is not really addressed in the ASHRAE and IECC model codes. So, for a long time, there's been some accounting for thermal bridging on the inside of the envelope, but not on continuous insulation and the exterior of the envelope. So I think even for small buildings, 20,000 square feet and below, that's going to be a major change for them. And doing the thermal derating work is eye-opening for some of the assembly types that we see these days, and less of a challenge for others. So that's going to likely move the market in small building construction as well. And that's the outcome that we want. We want better performing envelopes, and this is a way to get there. So if you would really like to see a prescriptive path for large buildings, then I'm sort of here to say we're probably not going to see that. We haven't really had that in the stretch code for a long time for buildings over 100,000 square feet. And now we're dropping that to 20,000 square feet. And that is similar to the percent better than change. That is a major change to the way we're thinking about building code in Massachusetts. And we're hearing similar things from some of the leaders in other parts of the country and across North America as well. So I don't think we're the only ones going down this pathway. I meandered on a bit there, but did that address your question?
Yeah, it did, kind of. Thank you.
I also want to point out that Passive House is also not prescriptive. It's very, very flexible of a system. It gives you a certain energy limit, and you can be flexible how you meet that. So when we're saying in the modeling community, when we're saying like Passive House equivalent envelope, it really is up to doing that Passive House model to finalize what those numbers might be for the envelope performance and air infiltration. So Passive House gives you limits on the energy use, heating and cooling, and plug loads. It also gives you the air infiltration that's required in continuous ventilation. How you achieve those numbers is really up to the design team, and the same, I think TEDI is trying to do that the same, but without the soft costs of having the Passive House designer. So we're at time this morning, so I wanted to go ahead and thank all of the presenters for generously giving their time to us and knowledge this morning. Appreciate the great discussion. We're all on pins and needles waiting for these updated modeling guidelines so that we can see if our projects can get through, especially those school projects that many of us are working on. And we're, it's also great to hear from DOER. Thank you, Ian, for joining us this morning and giving us all hope that if we email you, we can get some questions answered. and I look forward to seeing you all next month so we can dive more into thermal bridging and the envelope. Thank you.